Variables are the building blocks of any research project, acting as the measurable elements that researchers manipulate, observe, or analyze. Understanding how to identify, define, and measure variables is crucial for anyone involved in academic research, from students designing their first experiments to seasoned scholars tackling complex questions. This course will equip you with the introductory knowledge to understand the different types of variables. Hello everyone, my name is Taher Ben Yahya and welcome to our comprehensive guide on understanding variables in research. In research, variables refer to elements that have the ability to change or vary. They play a vital role in designing your research as they help us explore and understand the relationships and effects involved. So, what's a variable? A variable in the context of research is any characteristic, number, or quantity that can be measured or quantified. Variables can vary among participants in any study and are used to form hypotheses, which researchers aim to test through their investigations. In basic words, imagine it as anything that can change or vary. For example, how the weather changes or how every person has different favorite ice cream flavor. Variables are the building blocks of research. They help us explore and understand all different elements of what we are studying, whether it's places, items, people, or even ideas. Think of a variable as anything you are curious about. It could be something simple like how tall people are, or something complex like how people behave. What's fascinating is that the value of these variables can change. It might change from group to group or over the time. So next we are going to talk about the different types of variables. First, let's talk about independent variables. An independent variable is the factor in any experiment that the researcher intentionally manipulates or changes to observe its effect. It's considered the cause or reason for observing effects. Any changes in the dependent variables are hypothesized to be directly caused by variations in the independent variable. For example, in testing a new drug, the dosage is an independent variable. The independent variable is the cause and it causes the dependent variables to be changed. For example, the patient health. Like changing the motivation methods at work, it might change positively or negatively the work performance. If we are testing customer behavior, the attitude in this case is the independent variable. Key points you must know about the independent variables. The independent variable controlled by the researcher. As the researcher decides the value of the independent variable per the experiment or the investigation. Causes of change. It is hypothesized to be the cause of any change in the independent variable. The independent variables can have multiple levels. The independent variable can have 2 or more levels of different groups. And finally, the operational definition of the independent variables. The researcher should define this independent variable in this section if in any paper or research. Next, the dependent variables. These are outcomes of the response to the independent variables. The dependent variable is what the researcher measures to see or observe. It is changes as the result of the manipulation of the independent variable. It presents the outcome or effects in any experiment. The dependent variable is what the researcher measures to see or observe. If it changes as a result of the manipulation of the independent variable. Changes in the independent variable are considered to be dependent on variations in the independent variable. In our drug example, the health improvement of the patient is the dependent variable. Key points you must know about the dependent variables. First, outcome of interest. The dependent variable is what the researcher is trying to explain or predict. It is the effect or outcome that is observed and measured. Secondly, affected by the independent variable. The dependent variable is expected to change in response to the manipulation of the independent variable. Thirdly, the dependent variable measurement. It must be measurable in a reliable and valid way, allowing the researcher to collect data that can be analyzed. Finally, specific to the study. The definition and measurement of the dependent variable are specific to the study, similarly like the independent variable. Now we are going to talk about the moderating variables. Moderating variables affect the strength or directions of the relationship between the independent and dependent variables. For instance, the age of patients might influence how effective the drug is. So we can define the moderation as a variable modifies the effect of the independent variable on the independent variable. In basic words, a moderator affects the strength or direction of this relationship. To take an example, the effect of exercise on weight loss moderated by a diet. The independent variable in this example is the amount of exercise. The dependent variable is the weight loss, and the moderating variable is the diet. To explain this example, the effectiveness of exercise on weight loss might be stronger for individuals following a balanced diet than those who are not. Here the diet acts as a moderating variable, influencing the strength of the relationship between exercise and weight loss. To conclude, a moderating variable plays a crucial role in research or studies by influencing the strength or direction of a relationship between an independent variable and a dependent variable. Essentially, a moderating variable is a third variable that affects the relationship between the two main variables under a study. It can either enhance, weaken, or change the direction of this relationship. It's critical to understand that the moderator variable is not influenced by the independent variable. As a researcher, you may consider introducing a moderator variable when the relationship between the independent and dependent variables appears inconsistent across studies. This approach is useful if some studies suggest a positive relationship while others indicate a negative relationship. Moving now to the fourth type of variables, which is the mediating variable. Mediating variables explain the process through which the independent variables affect the dependent variable. In our drug example, the mediating variable could be the rate of drug absorption in the body. Mediating, or sometimes we call it mediator variables, play a significant role in research by explaining the processes or mechanism through which an independent variable influences a dependent variable. They help in understanding how or why certain effects occur by acting as a link or pathway between the two main variables or of interest. We can define mediation as a type of variable that explains the relationship between the independent variable, the predictor, and the dependent variable, the outcome. It helps to clarify the nature of the relationship between the two by revealing how the independent variables affect the dependent variables through the mediator. To give an example, the relationship between education and income, mediated by job opportunities. The independent variable in this example is the level of education. The dependent variable is the income, and the mediating variable is the job opportunities. To explain this example, the higher level of education can lead to a better job opportunities, which in turn can lead to a higher income. Here, job opportunities serves as a mediating variable explaining how education influencing income levels. To give another example, the impact of social media used in academic performance, mediated by study time. The independent variable in this example is the social media use. The dependent variable is the academic performance, and the mediating variable is the studying time. To explain this example, the increased use of social media might reduce the amount of time students dedicate to studying, which in turn can negatively affect their academic performance. In this case, the time spent studying is the mediating variable that elucidates the negative impact of social media use on academic achievements. When you have both moderator and mediation variables in the same research model, it means you are examining a more complex relationship that includes both indirect effects, mediation, and conditional effects, moderation. This diagram shows a basic research model have both moderator and mediation variables together. So in research model, we might have moderated mediation or mediated moderation. First, moderated mediation. The impact of X on Y through M depends on the level of W. But differently, the mediation effect is influenced by moderator. This means that the strength of the mediation effect changes across different levels of moderator variable. Secondly, mediated moderation, where the moderation effect of W on the relationship between X and Y is actually mediated by M. The mediation explains how or why the moderator occurs. Example with moderated mediation. Let's say we are studying the effect of job training, X, on employee productivity, Y. We hypothesize that job satisfaction, M, mediates the relationship. More training leads to a higher job satisfaction, which in turn leads to higher productivity. However, we also think that the relationship between job training and job satisfaction is stronger for employees who have a high need for achievements, W, the moderator. In this case, the mediation effect of job satisfaction is expected to be stronger for those with a high need for achievements compared to those with low need for achievements. So the indirect effect of job training on productivity through job satisfaction is not constant. It fluctuates depending on the level of the need for achievements. So now giving another example with the mediated moderation. Using the same variables we discussed before, but in a different structure. We might hypothesize that the moderating effects of the need for achievement on the relationship between job training and job productivity is mediated by job satisfaction. In this scenario, job satisfaction explains why the need for achievement changes the impact of job training on productivity. In both cases, these complex models allow researchers to explore not just whether variables are connected, but how they are connected and under what conditions. Understanding these dynamics can lead for more detailed findings and can have important implications for theory and practices. Finally, we will talk about the control variables. The control variables are constant variables during the research or the study to ensure that the results are due to the independent variables only. In our drug example, the control variable could be the environmental conditions of the lab. Control variables are essential elements in research that help ensure the validity of an experiment by holding constant factors that could potentially influence the outcome. By keeping these variables steady, researchers can be more accurate to determine the effect of the independent variables on the dependent variables, minimizing the risk of external factors skewing the results. Moving to the control variable definition, a control variable is any variable that is not of primary interest in the study, but is controlled or held constant to prevent its influence on the relationship between the independent and dependent variables. The purpose of controlling these variables is to isolate the effect of the independent variable, ensuring that observed changes in the dependent variables are due to the independent variables only. To give an example, the temperature in plant growth experiment. The independent variable in this case is the amount of water given to the plants. The independent variable is the growth rate of the plants. And the control variable is the temperature. So in studying the effect of water on plants' growth, keeping the temperature constant ensures that any differences in growth are attributed by water levels and not to the temperature variations. Another example, the age in study of the effect of a new teaching methods. The dependent variable is the teaching method. The dependent variable is the student test scores. And the control variable here is the age of students. To explain this example, when evaluating a new teaching method's effectiveness, controlling the age of students helps ensure that the results reflected the teaching methods only, rather than the age related or the ability of the students. So to conclude, control variables are crucial for experimental design because they help establish a causal relationship between the independent and dependent variables by eliminating alternative explanations. In the end, understanding these variables is crucial for conducting effectiveness research by manipulating and observing these variables. Researchers can draw meaningful conclusions and discoveries. After understanding the types of variables, now we need to learn about the various types of variables encountered in statistical analysis. By the end of this section, you will have a solid understanding of different types of data used to measure variables in statistical analysis, along with the skills to effectively identify, classify, and analyze variables in research studies or data analysis projects. There are two types of data, categorical and numerical data. These two types reflect different levels of measurements. The categorical data refers to type of data that represents categories or groups. These categories can be qualitative in nature, meaning they represent characteristics or attributes rather than numerical values. Examples of categorical data include gender, color, or nationality. Categorical data is often represented using labels or names and is typically analyzed using methods such as frequency tables, bar charts, or pie charts that reflect qualitative characteristics. The numerical data, also known as quantitative data, represents measurable quantities or numerical values. This type of data can be expressed in numerical form and can be manipulated mathematically. Examples of numerical data include measurements such as height, weight, or temperature. Numerical data can be further categorized into two subtypes: discrete data, which consist of separate, distinct values, for example, the number of students in a class, and a continuous data, which can take on any value within a certain range, for example, temperature or weight. So you may ask, why do we need to understand different types of data? That's because the way we measure data affects which statistical test we can use. Simply, you can only calculate certain things, like the average or the mean for certain types of data. If you try to use statistical test on data that's not suitable for it, you will get up results that don't make sense. So it's important to know what kind of data you have before you start analyzing this data. Alright, now we have got a handle on both categorical and numerical data. We are ready to go deeper. In each of these board data types, there are essentially two measurement levels. For categorical data, we have nominal and ordinal levels, while for numerical data, there is interval and ratio levels. Understanding these levels is crucial because they determine the precision of measurement. Why does this matter? Well, the level of measurement directly influences which statistical tests are appropriate for analyzing the data and which ones aren't. We'll go now to explain each level with some examples. Nominal data. The nominal data is a type of categorical data where the categories represents names or labels with no inherent order or ranking. Examples: categories like gender, male or female, material status like single, married, divorced, or types of fruits, apple, banana, orange, etc. Nominal data can only be categorized and counted. Arithmetic operations such as addition or subtraction are not meaningful in this context. Nominal data questions are frequently employed in surveys to gather demographic information like gender and ethnicity. This helps compare responses across these fundamental categories, such as assessing differences between men and women in survey responses. So, nominal data are useful for assessing differences between groups. Ordinal data. The ordinal data is a type of categorical data where the categories have a nature, order, or ranking, but the intervals between the categories may not be uniform or constant. Examples include ranks like first place, second place, or third place, levels of agreement, strongly agree, agree, neutral, disagree, strongly disagree, or educational level, high school, diploma, bachelor degree, master degree, PhD degree. While ordinal data can be ranked, the differences between categories may not be precisely quantified. So, ordinal level data consists of categories arranged in a specific rank order. Interval data. Interval data is a type of numerical data where the differences between any two values is meaningful and constant, but there is no true zero point. In interval data, zero does not represent an absence of the attributes being measured, but rather a specific point on the scale. Example: including temperature measured in Celsius or Fahrenheit, where 0 degrees does not mean the absence of the heat, but rather a specific point on the temperature scale. Arithmetic operations such as addition and subtraction are meaningful with interval data, but multiplication and division are not. The interval data shares the order nature of ordinal data, but differs in the interval between measurement points. The measurement points are constant and equal in the interval data, unlike ordinal data. Finally, the ratio data. Ratio data is a type of numerical data where the intervals between values are constant and there is a true 0 point, which represent the absence of the attributes being measured. In ratio data, 0 indicates the complete absence of the attributes. Examples include measurements such as height, weight, time, money. For the time, for example, the 0 second means 0 duration. With ratio data, all arithmetic operations, including addition, subtraction, multiplication, and division, are meaningful and valid. So the ratio data represents the most advanced level of measurements. Its 0 points hold absolute significance value. To recap what we have discussed before, so within these data types, we encountered two levels of measurements. Categorical data presents nominal and ordinal levels, and numerical data offers interval and ratio levels. Knowing these differences is really important because they control how accurate our measurements are. So the nominal data represents categories with no inherent order, while ordinal data represent categories with a natural order. The interval data represent numerical data with constant intervals but no true 0 points, while ratio data represent numerical data with constant intervals and a true 0 points. And when it comes to ratio data, we unlock even greater potential for sophisticated statistical analysis. Understanding these distinctions is crucial in choosing appropriate statistical methods for analysis and interpretation of data. Let's now look at a practical example from a real survey. This survey consists of approximately 62 questions that inquire about customer behavior toward mobile phone recycling. We will focus on the first 5 questions, which assess customer attitude. These questions utilize a 5-point Likert scale ranging from strongly disagree to strongly agree. Additionally, at the end of the survey, there are demographic questions also included, covering aspects such as age, gender, and education level. We will demonstrate how to import these questions into SPSS and design the appropriate data types. So to reflect this survey example to the SPSS tool, we have to start with the variables view to define the variable. As we mentioned, those 5 questions related to the attitude variable. So we start to define the new variable, we'll call it 81, which reflecting the question 1. SPSS will define by default some values as a numeric, and the label here is related to the question. So the question here, we'll put it in the label, and the values, as we can see, we have 5 values representing strongly disagree to strongly agree. So if we click the variables, we start with the variable 1, we'll define it as strongly disagree. The variable 2, disagree. 3 is neutral. And number 4 for agree. And the last variable for strongly agree, 5. Okay, so this is the variable. And the most important field to fill is the measure. In SPSS, we have 3 values: scale, ordinal, and nominal. A scale is reflecting the numerical values. Ordinal and nominal is the categorical values. And as we can see, this question is a quantitative question. So definitely it will be a scale, either interval or ratio. So there is no differentiation here in the SPSS. So we'll define it as scale. And we repeat the same for the question 2. So this is attitude 2. We can copy this value because are the same values, and definitely this is scale. Similarly for question 3, 83. We'll define the remaining later. 84. And the last question here as 85. The same values here, and all of them are quantitative, so they are scale. Now when it comes to the customer gender, or asking for the customer gender, so let's say here the 6. So, and this is a question, the gender, the values definitely is either male or female. 1 and 2 for male, and this is, as we learned, as what? Nominal value. When you ask about the education level, as we explained before, is an ordinal, as there are intervals but not constant intervals here for the education, and definitely we define those values here to measure. So the first one is less than high school, second is high school, third is bachelor degree, fourth master degree, and the fifth PhD or DBA degree. And after we create all the values with the measurements and the type of measurement or the type of data, we go to the data view and we put all the data here. For example, if the customer answers this as disagree, it will be 1, agree, it will be 4, etc. And this, if it's female, it will be 1. If it's PhD, it will be how many values for PhD? 5, and so on. Definitely sometimes we upload all this data because we collect all the data to Excel sheet and we upload them to SPSS. I will show you here an example for the survey we just observed. So this is the data. As you can see, all this data for the 62 questions, and those are the variables we collected from the customers to measure the customers' behavior toward mobile phone recycling. In the end, thank you for joining us in exploring the fascinating world of variables. Stay curious and keep exploring.